All right, 6.sp.2, describing a set of data by its center or its spread. That's the fun you're having today. So your vocabulary words are spread, and that just means how spread out a set of data is, how far apart the numbers are. We usually use range to measure spread. Okay. Another vocabulary term you need to know is box and whisker plot. This is a box and whisker plot. That thing. You've probably not seen too many of those. It's not super complex, although it looks really weird. It sits above a number line, and it's just basically taking all of the numbers of a set of data and splitting them into fourths. So this set of data could represent any amount of numbers. There could be 100 numbers right there on that box and whisker plot. If that's true, that means that a fourth of them are on that whisker, a fourth of them are in that whisker, a fourth of them are in this box, and a fourth of them are in this box. So, in other words, a fourth of the numbers from this set of data are between 1 and 3. So if that was 100 numbers, there would be 25 numbers from 1 to 3. There would be 25 numbers from 3 to 4. There would be 25 from 4 to 6. And 25 between 6 and 7. A fourth of the numbers fall in all those sections. There's no reason why this is a whisker and this is a box, as far as I know. That's what makes it all so weird. The other things you need to know about the box and whisker plot, which you could probably have figured out already, is this number right here, 4. 4 is the median. It's the middle of that set. And that makes sense. If there's a fourth and a fourth and a fourth and a fourth, that's halfway. 4 is halfway, so that's the median. 3 is halfway from the smallest to the middle, to the median. So 3 is what they call interquartile number. And so is, it's called the lower quartile actually, and 6 is the upper quartile. That splits the upper half. And 7's the biggest number. Okay, so that's box and whisker plot. You'll learn more about it later. Anyway, you can see a lot of stuff about data just by looking at a box and whisker plot. Now, next, histogram. Histogram looks like a bar graph, except that each bar doesn't represent just a certain thing. It represents a range. So maybe this is the ages of people at a family reunion, and there are 3 people that are from ages 0 to 10, and 4 people that are from ages 11 to 20, and 2 people that are from ages 21 to 30. And that's not very realistic because family reunions usually have only old people at them. We all know that. But I'm just trying to make up a situation for this, so bear with me. So a histogram looks like a bar graph, except there are ranges instead of single numbers representing the bars. All right, so notes. To describe the spread of a set of data, look at its range. To describe the center of a set of data, calculate the mean, median, or mode. Mean, median, and mode represent our measures of center. Range is a measure of the spread. Okay? So here's how you find those things. The range is the distance from its smallest value to its largest value. So you will subtract those two values. Biggest minus smallest gives you the range. All right, mean. To find the mean of a set of data, find the sum of the values and divide by the number of values. So you add up everything and divide by how many there are. Median. You line them all up from smallest to largest, and it's the middle one. It's the middle value when all of the numbers are in order. And the mode is the value that occurs most often. Okay. So refer back to those if you need to find them on today's lesson. So, example, find the median and the mode from the dot plot below. That's a dot plot, by the way. So, median, it's the middle number when you put the numbers in order. On a dot plot, the numbers are in order. So all we have to do is find the middle one. So how many numbers do we have in this dot plot? We've got 1, actually I'm going to highlight. We've got 1, 2, 3, 4, 5, 6, 7, 8. Oh, great. So the median is going to be between the fourth and the fifth, because 1, 2, 3, 4, 5, 6, 7. If there's 8 numbers in order, the median's in between the fourth and the fifth. So when I look here, that's the first number, smallest. Next, 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 that's fourth. The fifth number is a 12. So the median is going to be in between the 11 and the 12. I could list these numbers out in order. 10, 11, 11, 11, and 12, and 12, and 13, and 14. The middle number is between 11 and 12, so it's 11.5. So the median is 11.5. So when there's an even number of numbers, you have to split the difference. You have to find the average or the median or the mean of the middle two numbers. Okay? Mode. Which one's there the most? Pretty easy to see. In the dot plot, there's more 11s. So 11 is the mode. 11.5 is the median, 11 is the mode. Next problem. Your other examples. All right, let's get a better look at these. Jamie graphed the number of baseball cards that his friend had. After looking at the results, he thought, all of my friends have at least 20 baseball cards, but no one has more than 50. Select all of the graphs that could represent his friend's baseball cards. So they're from 20 to 50. Okay. So this one goes from 20 to 50. 20 is the smallest. 50 is the largest. All right. This one's from 20 to 50. There's nothing less than 20 and nothing more than 50. Okay. This one is not from 20 to 50. These ones here are from 20 to 30, 30 to 40, 40 to 50. Those are from 20 to 50, but this also includes these over here and these here that are smaller and larger than 50. So that one does not work. 20 to 50 almost, except for that guy and that guy. So that doesn't work. So it's just the first two. All right? Next question. A group of students solved 2 different puzzles. These histograms show the amount of time it took them to solve each puzzle. So I see puzzle 1 here and puzzle 2. And I see time in minutes. And then I see frequency. Frequency is confusing to some people. Frequency just means how many. Okay? It means the number of. So that's the number of students that took on puzzle 1 from 10 to 19. So one person solved the puzzle between 10 and 19 minutes. One person solved the puzzle somewhere between 20 and 29 minutes. Looks like 13 people solved it in 60 to 69 minutes. Okay, 13 people because it lines up with the 13, and so on. Okay. Puzzle 2. All right. So when you look at this, you can see that most of the people on puzzle 1 took that much amount of time, more than 60 minutes. Most of the people on puzzle 2 solved it quick. It looks like puzzle 2 is easier. All right, so let's take a look. The spread of the data for puzzle 1 is what compared to the spread of the data for puzzle 2? And those choices right here are going to be more than, less than, or the same. Greater than, less than, or the same. So the spread, that's from the smallest to the largest. So the spread of puzzle 1 is from 10 to 89. Okay. 10 is the smallest possible value because there was nothing from 0 to 9, but there was something from 10 to 19. So 10 is the smallest possible value. 89 is the largest. On this other one, it goes from 0 to 79. Okay, you can see that there could have been a 0 and there could have been a 79. So that's the spread. It looks to me like the spread is the same. Spread of the data for puzzle 1 is the same as, Okay, the same as the spread of the data for puzzle 2. They're not spread out anymore than each other. For the majority of the students, it took less time to solve puzzle 2. You can see because the cluster is on the less amount of time. On puzzle 1, the cluster is on the greater amounts of time. All right. Last couple of problems. Okay, Dan was going through the attendance sheet of his data class. I'm right here, by the way. As he looked over, he realized that the number of students who attended his class was between 10 and 24. Okay, so what this graph means is on 5 days, there were from 10 to 14 students. On 10 days, there were between 15 and 19 students, and on 15 days, there were between 20 and 24. Okay. So the question is the data display correct? Why or why not? This data display is correct because the range should be between 10 and 24. There's always between 10 and 24 students. The range should not be 35 and 0. That doesn't make sense. Okay. The frequency should not be between, should be 0 between 10 and 24. The frequency should not be 0 between 10 and 24. That doesn't make sense either. Frequency is the number of students in the class. Okay. Or actually, the frequency is the number of days that those students were in the class. So if the frequency was 0 between 10 and 24, that would mean that there were no days that there were between 10 and 24 students, and there was always between 10 and 24 students. So that doesn't make sense. So last one, the last choice, it says no because the frequency should be high between 0 and 9 and 25 to 29. That has nothing to do with anything. I don't know why they would think that from the story. So it's just this one. All right, last question. Goals scored by Bears soccer team players. Okay, there's another box and whisker plot. Okay, or they call it a box plot. The box plot shows the number of goals that the Bears, a soccer team, scored during a tournament. Got it. Use the box plot above to select all true statements about the graph. At least half the players scored 1 or more goals. Well, more than half of the team scored 1 or more goals. You can see because halfway, half of the players is right there. Okay, so over half the players scored 6 goals, or between 2 and 6. And so 1 goal is right there. 3/4 of them scored more than 1 goal. Each of the sections, remember, represents 1/4 of the players. That section, that section, that section, and that section. Okay, so true. The median of the scores is 2. The median of the scores is 2. 1, 2, yes, the median of the scores is 2 because that's the middle value right there. True. The mode of the scores is 4. We have no idea what the most common one is. Okay, it doesn't list all of the different numbers of goals, so we don't know that. That's the thing about a box plot, is it doesn't show all of the individual values. It just shows where each 4th of them lands. The range of the scores is 6. Yes, 0 is the smallest and 6 is the largest, so yes, the range of the scores is 6. There are 5 players on the soccer team? No idea. Doesn't show that. And there's probably more than 5, aren't there? That doesn't make sense. Okay, so that's it. It's time to do your quick check. Find the mean of the following. Here we go. You're on your own.